Hi, so our topic up for discussion is vertical projectile motion. There are three scenarios in which you would have to use vertical projectile motion. The first scenario is when you have a person on top of a mountain or a cliff and they are throwing an object from the cliff. Okay, usually it's a ball or a stone or something that the person can hold in their hand, because there are two ways that they can throw it. They can either release the ball or release the object from rest, so they're just going to drop the ball. Okay, and there's a second way of doing that. They can throw the ball down. A second and third way, or third scenario that we will encounter, is someone standing on a horizontal plane and they are throwing the ball up. Okay. The ball is being thrown up and then it falls to the ground. And the third scenario is a person or two people standing on the horizontal plane and they are throwing a ball to each other, which causes a combination of vertical and horizontal movements. So this will be Y and this will be X. In Matric, you will only do examples 1 and 2. Okay. When we're speaking about these examples here, okay, you can combine examples 1 and 2 in one question. This is often what happens. If a ball is dropped, it means that the initial velocity is 0 meters per second. If a ball is thrown, it means that its initial velocity will have a value. And that value we will now call X. When this ball hits the ground, or when both balls hit the ground, they would have reached the maximum velocity. It means that if this velocity is 10 meters per second, nowhere in the equation will any of the velocities, this is the final one, nowhere in the equation will any of the velocities then be more than 10 meters per second. It has then reached 10 meters per second. It has then reached its maximum value. We consider two more quantities. We consider displacement. According to your question paper's displacement is either written as X or Y. Either way, it depends on how you define it. So in this scenario, your X or your displacement will be from the point of the hand until it reaches the ground. The same with the scenario. In this scenario, or rather this one, the displacement is a bit different. Okay? So if the person is a specific height, if the hand is a specific height from the ground, you don't consider this height here. You will consider this height, and from the time it reaches the maximum point or the maximum height, and then consider this entire height over here from the point it reaches the ground. So you will then have two distances. You will have this one, and we call that X1, and you will have this entire one. We will call that X2. I don't want to jump around too much, but I also want to note that in this example here, V, or your velocity, will have reached its maximum, or at maximum height will be 0 meters per second. When it hits the ground, the wording very specifically will tell you how to understand that question. All through everything that you are doing, if you are working in the upward direction, you have to specify that up will make V positive and down will make V negative. Okay, so when you're considering this part of the equation, then V will be negative, or you can do that vice versa. The last thing to do, if you make this positive over here, the gravity will always be 9.8 meters per second squared. So at each point, wherever this ball finds itself, the gravity will always be the same. But the velocity won't always be the same, and the distance won't always be the same.